Okay, chapter 6. This is day 1 of class for us. So what we're going to focus on is how do we standardize scores. You watched a video on the general empirical rule and what percentages might fall above or below certain numbers, but what if we want to standardize the scores? And what I mean by that is, let's say we have a mean of 150 and a standard deviation of 20. And I want to know what is the percentile is 148. Well, 148 isn't one of the nice even up or down 1, 2, or 3 standard deviations. So I want to know what percentile. Again, percentile is the percent at and below 148. So I have to standardize this in order to work with a number like 148 that's not exactly one of the standard deviations away from the mean. So to standardize the scores, we call that a z-score, okay? So let's take a look at what's in blue here for a minute. So z equals x minus, this is mu, M-U, mu, it looks like a U with tails, divided by sigma, lowercase sigma, it's like a circle with the tail off the top. Now what does all this mean? Well, this is some value we're trying to find the percentage of. So this is our value that we're working with. This is the mean, and that's the standard deviation. This is z. It is the number of standard deviations that we will be away from the mean. So z is just counting how many standard deviations away from the mean. It's called a z-score. So we take the value in question minus the given mean divided by the given standard deviation, and we will calculate a z-score. So let's look at 148 then. So I need to use this formula for 148. So z will equal 148, because that's the number in question, minus the mean of 150, because that was the given mean when we started the problem up here, mean of 150, divided by the standard deviation of 20. So you have to set up the formula. Now you're going to go to your calculator and you're going to type in 148 minus 150, and now you have to hit enter before you hit divide. You have to hit enter. And now I'm going to divide by 20. And I get negative 0.1. Z-scores must be rounded to 2 decimal places though. So that'd be negative 0.10. So this is negative 0.10. I need 2 decimals there. So now I draw a normal curve. We know that 0 is in the middle. Negative 1 is over here. So if 0 is in the middle, negative 0.1 is just barely left of center, and this is negative 0.1. We always mark the z-score underneath the line. Now, percentile is at and below 148. So we're going to shade, because this is what we want, at and below 148. We shade that way. I have to use what's called a z-table to look up this shaded region. These are located in the very back of your book next to the random digit table. I have a copy of it right here. This is our z-table. We have marked a location, and then shaded below is the probability or the percent that it will happen. So now on the side, I'm looking for negative 0.10. So negative 0.1, here it is, negative 0.1. my second decimal goes across the top. So 0 is my second decimal. So I go to negative 0.1 over to the first column, 0, and I get 0.4602. So I go back to my drawing, and I label this shaded region 0.4602. That is the shaded part. This whole thing, remember, is equal to a full 1. This, from here over, is 0.4602. So if I move the decimal place twice, it is 46.02%, and I'll probably just write that as 46%. So, what percentile is 148? It's in the 46th percentile. Let me keep going. What percent are higher than 188? Well, 188 again doesn't fall nicely at one of the standard deviation marks, so I have to standardize the score. So I need a z-score. Z equals 188 minus 150 divided by 20. Again, the number minus the mean divided by the standard deviation. Go to my calculator. 188, right? 188 minus 150. Enter. I have to do that first. Divided by 20. Enter. And I get 1.9. Now I said I need 2 decimal places. So that's really going to be 1.90. 1.90. So I draw a normal curve. Positive 1.9. So again, if 0 is in the middle, positive is to the right, and positive 1 is about right here, positive 2 is out here, so I'm out here somewhere. It doesn't have to be perfect, but it should be relatively close so it doesn't play tricks on your eye. And I want to be higher than, so that would be shaded this way. That's all higher than. So I go and I look for 1.9. Back to my Z chart that's in the back of my book. Now, if I look up 1.90, 1.9, second decimal 0, I get 0.9713. 0.9713. Does this look like I have shaded 97% of this whole graph? No. So why does it give me an answer that doesn't seem correct? All Z tables give answers, give percentages and probabilities that are to the left of the Z line, always on the lower end. I said I want to know what's on the upper end. If this whole thing is 100% or a value of 1.00, then all I have to do is take 1.00 minus what's down here, and I'll have what's up here. So this is really this part of the graph. So this is 1 minus 0.9713. And 1.9713 is 0.0287. 1 minus 0.9713 is 0.0287, or 2.87%. And that's your answer. So when we work above, we have to do 1 minus whatever the book tells us. And the last one I want you to look at is what happens if it says let's go in between. So I have 2 numbers. I need 2 z-scores. So z equals 143 minus 150 over 20. Z equals 165 minus 150 over 20. I need 2 locations. So go to my calculator. 143 minus 150, enter, divided by 20, and we get negative 0.35. So this is negative 0.35. This one's 165. So I go whoops, that's a 4. 165 minus 150, enter. Divided it by 120, enter. 0.75. So now I make my normal curve. You always, always, always have to draw a picture. Positive 0.75. Well, here's 0. Here's 1. So positive 0.75 is back in here somewhere. So positive 0.75. Negative 0.35. Well, here's 0. Here's negative 1. So that's back in here somewhere. Negative 0.35. And between would be in here. Now, your textbook does not give you between. Your textbook gives you only what's to the left of any spot. So let's say I looked up what was to the left of 0.75. It would be all of this. All of that. If I could chop off what's to the left of 0.35, then what I would have remaining is what's in the middle. Let me just get rid of this. So again, I start with the whole thing and I subtract what's to the left of 0.35 because then what's left over is right in the middle. So I need 2 4-digit decimals from my book. One for 0.75 and one for negative 0.35. So 0.75. Here's 0.7, second decimal of a 5. 0.75 is 0.7734. So that's 0.7734. That's from here over. Negative 0.35. That's on the negative chart. So here's the second decimal of a 5. So I'm in this column. And negative 0.35 is 0.3632. So all I do is I take the big 7734, which is from here over, minus, because I'm chopping off, this 0.3632, and I get 0.4102, or approximately 41%. And that is the percent in between. So in class, we're going to work on percent below. Whoops, sorry. We're going to work on percent below, above, and in between.